Morning, Karthik.
Hi, Shubham.
Yeah, I heard a quiet sonic boom over a gray hills.
So after Pawan told me, I rushed to see that, but I missed it.
Okay, looks like we have roughly half the people. So we'll get started in a minute or so. Okay, so usual question first, though this time different answer. Before you guys start asking about homework, we haven't graded your homeworks yet. We were all slightly busy with some work, work in our workplace, so couldn't grade your homeworks yet. So don't worry about scores. We'll upload before next class. Just the usual survey. The two questions in the homework, were they easy or too easy or medium or difficult? Medium, okay. Okay, easy to medium. Okay, good. Okay, yeah. So we'll not spend too much time on that homework because most of you guys are saying it's medium. We'll just go to today's class. We'll just spend about 30 to 40 minutes talking about what was originally planned, and the remainder of the class will talk about projects that you guys can do. So next class is on December 14th. There is no class on December 5th, I think. Actually, let me check. Maybe I'm wrong now that we missed last class. Maybe I'm wrong now.
14th, the 14th falls on a Monday.
Monday. Okay, so December 5th. Okay. So for the class of December 5th, we'll have a class. So this class will not have any homework. And even next class, we can skip homework if you guys want to opt for the project. Basically, the class on December 19th is the final class for this session. So on December 19th, if you guys want, from now to the rest of the course, which is roughly 1 month, 2 days short of a month, you can work on your individual projects. And today we'll discuss about a few project ideas. If you guys have any other project ideas which you have not already worked on before, if you have already worked on it before, don't talk about them. But any project ideas, then maybe we can discuss over email in the next week or so. And by November 28th, if you guys choose your projects, you can continue working on those projects. So in today's class, we'll just talk about recursion, which is one idea, and then project topics or project ideas. Okay, so let me share my screen. Okay, cool. So yeah, next year it will continue. Yeah, it was a group project. You guys can choose groups. I thought I mentioned last week already that yeah, just this year's session is over. Group project, yes. Yeah, no, this is only first 6 months of the course. There are 3 more sessions basically. So it's not done. It's just yeah. So just to answer you guys' questions, this is the same as your school usually, right? Like it ends in December and again starts in January. So same style. And it's a group project. If you guys form your own group already, I think only one group submitted their names. I don't remember. I think Shreya and Divya, I think. I don't remember the names, but only one group submitted their group names. Nobody else submitted. So you guys can form your groups and submit names. Anyway, so let's talk about this week's topic. This is recursive function calls or recursion. So how many of you remember while loops? Okay. Okay. So just as a refresher, I know all of you guys will probably now know exactly what to do, but write a while loop to find like the sum of the first 100 numbers. Write a while loop to find sum of first 100 numbers. You guys can all try and then message when you're done. Don't message the code or don't message the answer. Just message when you're done. Very simple while loop. Nothing fancy. Just as a refresher for everybody. So sum of first 100 numbers using a while loop. No for loops, just while loop. Oh, of course, for is easier, but I want while actually right now. Of course, for is easier. You don't even need for, right? We discussed list comprehensions. You can use some list comprehension based way, generate a list, and then you don't. You just sum up the list. Which is kind of for loop, so not much different. But yeah, just getting a feel for while loop, because we'll use that as an idea to use this recursive function, approach this recursive function calls. So message in the group as you are done coding your while loop and you get the answer. So from sum of 1 to 100 using a while loop. Is it taking you guys this much time, or are you just waiting because you don't want to be the first one to say you're done? Okay. Okay, so technical problems. Okay. Interesting. Two people collab not working. Wow.
I managed to catch the vibrations of the rocket launch on a seismogram.
Oh, very nice, Jonathan. Okay, interesting. Everybody, a lot of people are having issues today. Okay. Maybe it's just the holiday mode. You guys are all ready for holiday mode, and your machines are also ready for the holiday mode. Yes, you have to use while loop, yeah, because I'm going to exactly parallel that with whatever we are going to learn today. So that's why refresher on while loop for all of you guys. You refresh your memory by 9:45. If we are not done, then I'll show the quick one. No, just the sum of first 100 numbers, 1 to 100, sum of the whole numbers from 1 to 100. Okay, 1% done. Okay, no problem. If your collab is not working, just keep trying. Not much you guys can do. Okay, 4 people done. Okay, somebody pasted the code. Okay, cool. So now that someone has given the code, so we'll just get nothing really hard. So sum of first 100 numbers, so you use a variable, whatever you want to name it. You start with a number equal to 1, right? While number less than or equal to 100, sum of first 100 numbers less equal to number, right? Nothing interesting, and just a very standard thing that you guys have all done long time ago, and then print sum.
Is it the first 100 whole numbers or from 1 to 100, the sum?
1 to 100, yeah, 1 to 100. Yeah, there is no trick here. It's a very simple question. I'm not trying to trick anything. It's just a simple question. The reason I'm asking is, oh, why do I use, yeah, you can use sum of, that's just shorthand notation using that plus equal to, you can use this way also. No difference. Oh, zoom in, yeah, sorry. Is this clear? Can you guys see now? Okay, cool. Okay. Shreyan, answer equal to 0. Isn't that the exact same thing? You just use different variable names, right? So you started with 0. Yeah. Okay, good. So, okay. So very simple one. What did we do here? We had like a initialization, right? Then we had loop increment and some termination condition. And what is this statement roughly? This is the actual some command execution. Right? This is executing the command that you want or calculating the thing that you want. So while loop, as we saw, a simple while loop like this and almost all while loops typically end up having 4 conditions, right? You need to initialize some variable, which is typically called as loop variable. Then you change it, whether you increment it or whether you set a true or false thing or whether you do some other thing with it. You change it, loop variable change. And while that loop variable is within some range, you keep running the body of the while loop and it keeps doing some work. Very simple concept, right? Anybody remember, like, so if without the while loop, what would we have done here? If there was nothing like a while loop or nothing like a for loop, how would you have done the sum of first 100 numbers? Manually, okay. But if you have to use a program, so how would you do? So you could start something like this, yeah. Well, some keyword actually relies on the existence of while loop or for loop, right? So I could say sum equal to 0 and sum equal to sum plus 1, sum equal to sum plus 2, and so on, right? This is a way to add it up, right? 1, 2, 3, 4, 5. Yeah, absolutely, you can add up 1 plus 2 plus 3. So it's a lot of typing. The motivation behind going from this, so this is simply that these statements are repetitive, right? These statements are repetitive. Whatever the operation, you are taking a number, you are taking the variable sum and adding first number to it, second number to it, third number to it, and so on. Since we had repetitive state commands that we were executing, we just realized, okay, I could use a loop variable and keep changing that loop variable and repeat the same command every time. So that's the motivation, right? So this is the same as number as we change number by 1 each time as we increment the number by 1. I mean, I'm just refreshing a while loop just so that I can introduce recursive function calls using similar style. Does this all make sense to you guys? Okay, cool. So while loops, or even for loops for that matter, are very good if you have a good termination condition or well-defined termination condition, right? Like some number less than some number or greater than some number, or till some condition is true or till some condition is false. So that's a good use case for using while loops. However, sometimes in real life, you don't necessarily have a well-defined termination condition. You're all familiar with one such example, and that's exactly what I'm going to use in today's class. So you guys can go to your own computers, but this is the drive structure on my computer, right? You can see C drive, D drive, right? Can you still see my screen? Hopefully, yes. Okay. Okay, so in D drive of my computer, I want to know what is the size of all the files. Of course, my computer already is calculating this. All of your computers already do that. But if I want to write a program to calculate that, what is the size of the contents in D drive? How can I do that one? You guys can type, or if you want to speak out the answer, you guys can message you want to talk about the answer, and I'll ask each of you to, or someone of you to answer. What is a D drive? My computer has 2 drives. These are like partitions on my hard disk that I store different files on. So these are all the folders I have on my computer. You guys can go to your own computer, whether if you guys have Chromebooks, I don't know how it looks for you. I haven't used a Chromebook myself, but if you're using a Windows, or use a for loop with args. Okay, what is the args? Then loop through every folder. Okay, so let's say I loop through first folder. So I loop through this folder, right? So Prince has a good starting suggestion, which is, I'll say some starting folder equal to something, maybe D colon, and then loop through every folder and do what, Prince? Loop through every folder and do what? So Mugil already said that, loop through every folder and find the size of each file and add it up. Extract the first. No, we want to add up the size of each file basically to find out what is the length of, what is the total size of all the files in the folder. Of course, some of you guys who are familiar with file IO. Okay, so you loop through every folder and find the size of each file and add it up, right? So let's just look at it manually. First, we are looking at it manually. So this is my first folder. It has some Windows related files. I don't know what these are, but each of these files or most of these files are 18 kilobytes. Can you see on the screen? So I can probably find the same thing. Do you guys know how to find out the length of a file? How do you find out the length of a file? Anyone?
What was the question again?
How do you find out the length of a file? If I give you a file name, how do you find out the length?
Lengths and with a parentheses.
Okay. On your collab sessions, if you are using collab or if you are using PyCharm or whatever on your Windows, on your collab sessions, you have a file browser here, which has some sample data. Try to find out what is the size of this California housing test.csv. What is the length of this California housing test.csv? The answer is already there. If you look at it on the screen right now, it says 294.08 kilobytes. So that's the answer. Try to find that on your collab session. You guys all tried this already a few classes ago. You used the file. You can read the file and then find the length of the file. Oh, anyone doesn't matter. Test one, yeah, test one seems like 294 kilobytes. Train one seems slightly larger. You can use the test one. What is the size of California underscore housing underscore test.csv? This should be there in all your collab sessions. If you're not using collab or if you're using some other thing on your laptop, you can pick any file that's there on your laptop. You can pick any file on your laptop and you can try to find the size of that file. Okay. So one way that we have seen, anybody, any thoughts so far? Have you guys tried it? No thoughts? Okay, so let's see. How many of you remember file, how to read a file? Okay, how do you read a file? Well, how, yeah, okay, how do you read that? Yeah. Okay, you do something like file pointer or file equal to open of whatever is the file name. So California, in my case, California housing test.csv, and you could say read, right? And then f.read or file pointer.read, right? And what does this do? This reads the file, right? So again, I'm not saying this is the only way. This is just one way that we have all seen in the past. So what can we do now? What if we try length of file.read? Would that work? Oh, I have to do this sample data slash, what is the path of this file? Let's see, copy path of the file. Oh, content sample data. So I copied the file path wrong. Okay. So it says this is the length of this file, 301,141, right? Right. So this looks fine to you guys. Like, any questions? Does this look okay? You guys are following what I'm doing here? Okay. So I'm just opening a file, reading it, and finding the length of the file. Isn't that wrong? Oh, 294 kilobytes. So if I take 301,141 divided by 1024, that's 294.08 kilobytes, exactly the same. So it's slightly, yeah, 294. Yeah, I don't know if you can see this tooltip that it's showing up here, but it says 294.08K. Can you see that on my screen when I show? Why am I dividing? Because file lengths are measured in bits or bytes. One byte is 8 bits, and each bit is like a binary thing. So it has 2. So it's in base 2. So in base 2, 2 power 10 is equal to 1024, and that's called as 1 kilobyte. So it's not exactly 1000. It's not like 1 kilo is not 1000 in base 2. 1 kilo is 2 power 10, hence I'm dividing by 1024. So again, very straightforward stuff. So all I did is this. Now you guys, please try to write a loop. Actually, before you try, maybe I'll help you guys with this. So right now we want to simply go through all the files in this particular folder. I'll write a small loop to go through all the files in this particular folder and add up their lengths. Okay. Yeah, I'll put the link in chat. So for doing that, there is a library. Like all things in Python, there is a library. Maybe there is a way to do without the library. I'm not familiar with that way. If any one of you know, please let me know. We'll use that non-library based method. So there is a library called OS. Has anyone used this library in the past? Okay, so you have used OS. Okay, cool. Anyone else other than Satvik? Okay, no problem. We'll go over this one today. So there is a library called OS, and in that library there is a method called walk. Or actually, let's use. There is another method called list.dir. So I'll say from OS import list.dir. This list.dir is just going to list all the files. OS is for operating system. Yeah, you're right. OS is for operating system. and list dir is for listing the directories that are there in a given folder. Okay, sorry, listing the directories or listing the files that are there in a given folder. Okay, so let's see what this list dir does before we go forward. So I'll just say list dir of this folder. I'm commenting out. Actually, let me put this in another cell so that we can continue without interrupting that cell. So let's see what this does. So as you guys can see, it returned a list of files in that listed in that directory, right? Can you see this? So this is a list. So now you can loop through this list and say for file name in list dir this. Now what can you do? Now we want to find out the length of size of each of these files and add them up. So what can you do? This is exactly the same as adding up sum of numbers. There is no difference here. We are just using a loop to do something else by looping through a different list, right? So nothing fancy, just exactly the same idea, but with a different loop variable and with a different list. Why do the files show up now? Because I don't think they get stored in any order. I don't know if I run this multiple times, whether it even gives the same order. Maybe it doesn't even give the same order if I run it multiple times. Okay, so how do you proceed next? So I want to now read each file. If you guys are using Colab, you can please try doing this as I'm doing or even before I finish. So the next thing is we want to get a file pointer, right, for each of them. We want to get a file pointer. So let me just close this file. So I want to just do file pointer and then open off. As you saw here, we need both the folder name and file name to read a file. Okay. So the folder name is this. So I'll say directory equal to this thing. And I'll leave directory here. And then I can open directory plus file name as a read thing. I'll just print file name comma length of read file pointer dot read, and I'll close each one. That's just to say I'm reading the file and not writing the file. I'm not writing into the file. So this sample code here works. So you guys can try it on your computers. So this is a sample code to just read. I just pasted in the chat window. This is the sample code. You can use some other code. I have no problem. You can try whatever other way you know. This is a code to just read through files in a loop and then find their lengths. After you try this on your computer, if you are in Colab or if you are in your own computer, try it on your own interface. Maybe you have to change the directory name. I would like for you guys to try to find out the total directory size. So add up each of these numbers that you get and find out the total length. And then you can message when you're done. Don't message the answer, just message when you're done. So you can try for the next 3 minutes or so. Okay, done, very nice. Do we have to find out how many bytes are there in the file? This is already finding out, right? This length of file pointer dot read is already finding out how many bytes there are in the file. So I just want to know what is print total size of all files in the folder. And we'll call that folder size, and I want you to print that folder size. So I want you guys to find out, write the update, change the code that I gave to actually find out the folder size and print the folder size, and then it will print automatically. So I'm going to give you this code, which is almost the same. Okay, good. 2 of you are done. So you just have to calculate this folder size, nothing else. It's exactly the same as looping and adding up numbers. Okay. Okay. So anyone else? Are you guys trying? If you have any questions, if you are not clear, if you're confused, why is it saying total size equal to 0? Because you didn't do anything probably with the folder size. I already declared a variable. Yeah, sure, that's fine, Nipun. Yeah, you can do that one. I don't. Mine is showing because I didn't add up, right, Shreya, and I didn't add up anything. I just declared and I'm printing. I want you guys to go add the code, write the code to find out the folder size. How do you get? I don't get that, Vijeta. That's just the name of this folder. So if I go here and say copy path, it's showing me that this is the name of the folder, right? It's telling me that the name of the folder is content/sample data. You can pick any folder of your choice. There are a lot of folders. I don't know if you can access all those folders, but there are a lot of folders. And if you guys are using PyCharm or some other thing, you can try that. You can try to pick a folder on your own computer. Okay, so I'm just trying to finish the easy thing here. So I'll just add up this thing to folder size, right? So now, oops. Oh, sorry. So I'll say file size equal to this. And instead of reading the same file twice, because it won't do any good. So now the total folder size it calculated is, I think, yeah, no, it already has it, right? It has some files. Google luckily uploads some files. Oh, so Medha, the problem for you is, I think, between sample data. So the file name is actually sample data and then a slash. You are missing a slash, Medha, after the sample data, right? So the actual file name. So let me print the full file name here. Is this? So the full file name, as you guys can see, is /content/sample data /anscomb.json. What is the error you are getting, Aditya? Actually, can someone maybe like set up a breakout room? So when you upload a file to Collab, it's public for everyone. No, it's within your session. These are files that Collab uploads by default for everybody. That's why they are in all of our sessions. If you upload a file, it's only in your Collab. I think .ipynb is a directory error, is a directory. So Tanishka, in your case, the problem is .ipynb is a folder, not a file. So you probably have to, listdir is a command or a library, that is library command that's already there. It is listing all the files in a given folder. So there is a way to check. I think so. Tanishka and Aditya, for you guys, it looks like you have uploaded some extra things in your code. So you can add this extra if, I think, if is file of this. It is file of this, then do all of this. So let me see if this works. Nope. Is file, maybe os.is file to check. Nope. Os.path from os.path import is file. Okay, now it should work. Yeah, so you guys can try with this code and see if it works for you guys. Yeah, exists will still work, Satvik. Folder also exists, right? File also exists, folder also exists. So Medha and Tanishka, or whoever else is getting that dot Aditya and Tanishka, you guys are getting that dot IPYNB checkpoints. If you try this, you should probably not get that one. Okay, cool. Okay, so what did we do here? Yeah, 56823521 is the answer. Yeah, absolutely. So we'll just go over this. What did we do here? Ignore this top part. We'll come to this. What I did is I have a directory here. Can you guys see my screen? I have a directory called sample data. You're all used. Does someone not? If you're not familiar with this idea of a directory, maybe you can watch a YouTube video or something and see how files and folders are there on your computers. But I'm assuming all of you guys have used some sort of a folder structure to store your report or to store something. So this is a directory or a folder, and these are files in that folder. So I'm saying this is my directory /content/sample data, and I declared a variable called folder size and I set it to 0. I'm just looping through. I'm asking this list directory function to list all the directories that are there, all the files and folders that are there in this directory. And then I'm checking if a given file is a directory or a folder. So just to illustrate, if you see on my screen right now, these top things are folders, right? These bottom things are files. You guys can look at your own computers and maybe some of these similar things are there on your computers also, right? So these are folders, these are files. We want to find out what is the size of all the files. We don't want to find out what is the size of folders. We want to just find out what is the size of all the files, add it up, right? So that's why I'm checking if a given thing that this list directory returns, is it a file or not? If it is a file, I'm opening the file, reading the entire file and finding the length of that, and then adding up that to the total folder size. And finally, I'm printing. Is this not clear to somebody what I'm doing? Because we will add on to this thing to see what to do next. Is this clear to?
Can you explain that again?
Okay, so I started off with a directory, right? This is the directory in my collab session. So if I see here and I say copy path, I get that one, right? So this is my directory name. So I started off with that directory, and this list dir function that I have here, that I imported from OS, prints all the names of files or folders within that directory. Okay. Yeah, you can definitely use other functions, like you can use that OS path get size, definitely. Yeah, we'll get to that one also. So this is just giving the list of all files. Right, the directory is a folder. Okay, if you guys are familiar with folder, we'll go with folder. So folder. Okay, so directory is just. Oops. I should have replaced all of these myself. Okay, so let's see if this runs. Okay, so directory is a folder. Are you guys are probably. Yeah, no, I don't want to use some other ideas, Nipun. We'll see. We'll talk about that. Some of those are really very silly ideas. Yeah, so we'll start with the folder, right? From the folder, this list directory of folder gives me a list of all the folders and the files that are there in that folder. right? Does that make sense? Now I'm looping through that list. As you can see here, this is giving me this list. Now I'm looping through that list and adding up the folder plus file name so that I get the full file name, because you need full file name to access any file. So this is the full file name. What does list dir do? Okay. Can you please try on your own computers this particular thing and check for yourself, like list dir of folder. Check this on your computer and then we'll continue. So all of you, please just try this small code on your collab session and see, and then you tell me what does list dir do. Meda or whoever else asked just now. So try this piece of code on your computer and then tell me what is it doing. Anyone else? Gives you the files in the folder. Is that, I mean, that seems very straightforward, right? Yeah, it gives the files in the folder, right? So these are the files. You can see the files in this folder, and this is giving me the list of the same files: readme.md, anscombi.json, minitest or mnist.test, mnist train small, California housing train, and California housing test. Just so that you guys know, this MNIST is, I think, like some number OCR database. These are very common machine learning data sets, very popular ones. Though the California housing one is just because Google is in California. This is one of the most popular machine learning data sets. Yeah, it printed a list of files, right? So list directory just gives you a list of files, right? So list dir gives you a list of files in that folder. So loop through the list of files in the folder. Okay. Then check if a list of files or folders, because a folder can have subfolders also, right? Check if a given list entry is a file, because if it's not a file, then you can't read a folder directly. You can only read a file using this command, right? So that's why I'm checking to see if it's a file. If a given list entry is a file, then open it. Read and find the length of the file. Add it up to the total folder size. Print file read and its size. Close the file. You have to close the file. I think that's just a good practice. And then finally, is this just a review class? No, this is a recursion class. We'll study recursion shortly. And then finally, print the total size. So if this is clear to you guys, now we'll keep trying. This is more like an exercise hands-on class. I'll not be talking because this one is it only makes sense if you try it by yourself. So right now you have a simple piece of code that finds out the size of all the files in a given folder. Make sense? Okay, I will put this code in the chat. Okay. Actually, I'll share my collab link so that you guys can actually easily I have to minimize a little bit. Okay, so this is my collab link. You guys should be able to go there and take this code. If the formatting in the chat window was not good. So this is the code. Now, whatever you guys have tried in the last few classes, please create a function that accepts a folder name and then returns the folder size. You can take this exact code and create a function. Whatever you want to call that function is up to you. Create a function that takes a folder name as input and returns the size of all the files in the folder as the output. Very simple function. Please take a shot at it. You have 2-3 minutes. You can try and convert this direct code into a function. So the task right now we are attempting is create a function that accepts folder name as input and returns size of all files. No, sum of size of all files in the folder. So that's the task we are trying to. You guys can write any function. It's up to you. You can call your function whatever you want. Is the task clear? Like, is it clear what you guys are trying to, or what I'm asking you guys to try? Okay.
Wait, so are we taking the folder name and figuring out the sum of the like length of all the files in the folder?
Yeah, your function should take input as the folder name, and the output your function returns is the size of all the sum of the size of all files in the folder.
Okay, thank you.
So just to give you a sample, so folder size is a simple function name, folder name, and then you can do folder size. Right, so this is a sample function. Of course, you have to put the actual code in between here. Okay, anybody, if you're done, you can let us know so that we see if you have a question, please let us know. We can break out into a separate collab room and sorry, not collab room, separate breakout session and try. Okay, has anyone finished it yet? Okay. You can use the same thing basically that we have here that we were trying in the previous part. So I'll just go over it. If you guys are trying and if you want a couple of more minutes, please let me know. Otherwise, I'm assuming you are all done or you're all stuck. Okay, 2 done, 3 done. Okay. So Shreyan, you use this thing basically. You import ease file from OS path, import ease file. Oh, so Shreyan, you were using that os.path.stats, right? Was that what you were using? No, I'm not sure. So what were you trying to do when you got this error? What was the command on the line where you got this error? It'll show you like the line number or what's the command on that line, right? Okay, so no, I mean, your code is giving you an error, right, Shreyan? When you run your code, it gives you an error, right? It in the error window where it's showing you that there is an error, it is also probably showing you which line is it failing on, which line did you get that error on. What is the, if you go to that particular line, what is the command that you have on that line, or what is the statement that you have on that line? Oh, so you gave your input wrong, I think, Shreyan. So your input should be folder, not file. So you should give this as input. Okay, so we'll continue just so that we finish this one and get to the next part. So I'm going to take the exact same code that I used already and convert this into a function. So you guys probably remember, like, there is not much difference. So for file name in list dir of folder name, does import a file? No, Vidyut. Import does something. For now, just this import is actually importing the functions that are defined in this particular module. So all these things that we are doing were list dir, right? It's a function. List dir is a function. Is it wrong to put the import inside of the function? I don't think there is anything wrong with that. Yeah, you can put it in the function, but probably better to put it outside. Yeah, no, I don't know. I don't think there is anything wrong, but it's a most standard practice to just import outside probably, but you can try either way. So I'm just saying folder name plus file name. So if it's a file, then I want to read exactly the same way that I did already. Nice. Yeah, you can try those things. You can try OS path. Yeah, you can try that one. It also works exactly same. So you can try that one. Definitely, that's a good idea. But the thing is, if yeah, so file pointer and then total folder size equal to total folder size plus length of file pointer dot read, file pointer dot close. So let's see if I create this function and call it with so it gave me the answer, right? So what did we do? We used a simple for loop through a list of files and gave the length. This is what we have learned. We have done multiple times for multiple collections, right? Nothing, hopefully nothing difficult other than the introduction of all these is file and list dir. The idea is simply there is a list of files. You're reading, you're checking whether the item in that list of files is actually a file, and then reading the file and finding its size and returning the total size of the folder, right? Is this idea clear to everybody? If the actual statements are not clear, you guys can try it after the class and see. Why are we doing folder name plus file name? That's because when I try to copy the path of this file, right? If you see, it actually copies folder name plus file name, right? Because if you just have the file name without the folder name, then which folder is this file in? Maybe I have the same file in 4 different folders. How should open know which folder it is in? Does that make sense? So that's why you need to know the folder name and file name if you are trying to read a given file. So our function right now is looping through the list of files in a given folder, and then finding out the length of each of them and adding up. Now, I want you guys to try to upload a folder into this one. So you create a new folder or you upload a new folder. So I'm going to create a new folder here called test folder 1. And I'll upload a few files into that. You can try this on your own computers also. Upload a few files into that one. So let's see, I'll upload maybe these EULAs. Hopefully because they're all text files. Okay, so it's giving me some reminder and it uploaded. So you guys also try on your own computers. You simply click on this file called sample data and choose create a new folder, and then go to that folder and click on upload. At the right hand corner of that folder, you should see these 3 dots, and then click upload and upload any number of files. It doesn't matter how many files you upload. You can upload as many files as you want. Did you all upload? Whoever is using Colab, if you're not using Colab, you can try some other folder on your computer. Okay, cool. So now run the same function. Now call the same function and see does it. Now we have added more files to this folder, right? We should expect the overall thing to return a larger number. So when I called it previously, it was giving me this number. So I'll store this number here. Now let's call it again and see. It's giving me the same number, right? Do you see that it's still giving me the same number? Is it doing the same for you guys as well? Anyone who has tried it already, is it giving you the same number for you guys, or is it giving you some other number? Yes, it is never going into test folder 1. Yeah. So let's see what's happening here. So when I go to list.dir and I put this file name, or this folder name as its input. See what does in my list, right? It's giving me just 2 folder names. These are 2 folder names. These are not files. These are just folder names. So what is this list.dir doing? This list.dir is just looking at the folder once like this, and it's telling me this is a folder, or this is one of the items, 2nd, 3rd, 4th, 5th, 6th, 7th, and then a hidden item called IPYNB checkpoints, right? You can go to my Colab session that I copied. Go to my Colab session and I just copied it again. From there you can get the code, or you can follow. If you refresh, I think it might even refresh. Listed exactly. So Prince has a good point. So what should you do if you want to get the remaining folders? I mean the remaining files. Now you have to do list.dir of test folder 1, right? So now if you notice, when I do list.dir of test folder 1, it's giving me the remaining folders in this list. So when I do list.dir of the top folder, it's just giving me the files in that folder and the remaining folders. So it's giving me both the list of files in the folder and the list of folders in the folder. And if I go through the individual folder, it's giving me all the files in that folder, right? Now, how can you make your function that we wrote earlier? How can you make this function continue one step further? Like now I want to change this function to add up the sum of the lengths of files in this folder as well, in this tested folder 1 as well. How do I do that? Any ideas? Do a separate case. Okay, so do a like a separate for loop. Okay, let's see. That's a good idea. Not at all a problem. So where do you want me to put the separate for loop? So when I get my list dir, I got it like this. Do you want me to put a for loop within this? When I'm looping through this list, do you want me to put a separate for loop? Any thoughts? Anybody? Outside? Okay, so you mean like outside of this whole for loop? Okay, but I don't know what is the name of the directory, right? I named it test folder 1. You might have named it something else. Somebody else might have named it something completely different. So how should I avoid that problem? I don't know what's the name of the directory. Here, since I got the name of the folder, I could loop through list dir of that. But if you want me to loop outside, yeah, so check a file or folder. So now I am already checking it's a file, right? So when I did list dir, I'm already checking if it's a file. Else, I'm assuming if it's else, then it's really just a folder, right? I'm assuming that. And then can I repeat one more for loop here? Does it make sense to repeat a for loop? Okay, so for file name in list dir of, or for sub file name in list dir of file name, same folder name plus file name, exactly the same thing. Right, so now I'm going to repeat exactly the same thing. But now because my folders are in 2 folder depth, so I have to do folder name plus file name plus sub file name, right? Does this make sense? And I also actually have to put a slash in between so that I get the full name. So just to illustrate what I'm doing, if I copy the path of this particular file, notice it is folder name. This is our folder name. Then our second folder name, then a slash, then the file name, right? So again, I have to check if folder name plus file name plus slash plus sub file name is a file. Then folder pointer this, and then total size is equal to total size plus this, and then close this one. So does this make sense? If anyone is confused, please let me know. I'll walk through it one more time. What I'm doing here is I'm initially looping through this, right? It prints this, it gives me this list. In this list, I'm checking if a given item is a file. So this is a file, this is a file, this is a file, and these 6 items are a file or files, and this is a folder, right? But what if inside the file there is another file? Inside the file there can't be any file, right? By definition, file is the final item you can have in this folder. Inside a folder you can have a folder, but inside a file you can't have another file. Right, yeah, that's a good point actually, Prince. Yeah, absolutely. So right now we are going there. So what did we do? We first went through all the list of files in a folder, found out their size. Then we found out that some of the items inside the folder are actually folders, and then I wrote another for loop here. From the look of it, is there any difference between this for loop and this for loop, or these two? Do these two for loops look like they are the same structure? Oops. Do you see they look like the same structure? When will you ever need to find the size of a file? Actually, Shayan, a lot of cases, right? Like if you want simple things, Like in your Google Drive, you're uploading files and the total file size is some 6 gigabytes and you have only 4 gigabytes left. So if you are trying to write code, a lot of big data stuff is actually a big headache because storing the data is a big problem. So of course you won't find the file size this way, you'll find with other methods. But yeah, this is absolutely not about how to find out or what to do to find out the file size. This idea here is to introduce the same reason. When will you find out the sum of 100 numbers? You'll never find out the sum of 100 numbers in real life, right? That was the idea used to. Why do you use else? In this screen that you, yeah, at 11 we can take a break. In this screen, do you see anything other than files and folders? Text is a file, right? These are folders. The remaining ones are all files. Everything else is a file. So all of these are files, all of these are folders. So in a folder, you can only have folders or files. Yeah, you can call them documents, you can call them files. Wait, is the one that says application is also a file? Yeah, this is a file, this is a file, this is a file. They're all different types of files. Yeah, exactly, Prince. Yeah, we'll get to that one. That's a very good question, Prince. You're going in the right direction. These are all files. These are all folders. So that's all. Within a folder, you can have either folders or you can have files. How can we expect infinite folders in folders? Actually, you guys might want to read about that. It's called, I think, zip bomb. Yeah. So don't download this. This is called zip bomb. There are a lot of publicly available copies. If you download this file, this is like a zip file. I'm hoping some of you guys have used a zip file. If you download one of these zip bomb files and try to open them, your computer will basically crash. At least some computers will crash. Basically, it's a file, a folder within a folder within a folder within a folder within a folder. It's an infinite recursion, so it just crashes. Of course, there is not infinite recursion. There is a trick with which they make it look like there are infinite folders. It's a very small one. It's just a 42 kilobyte size of compressed data. Why does it exist? Because there is because of the problem we will discover in like 15 minutes from now. Zipbomb is a popular virus. It's an old one. It's not recent. Okay, so continuing on, is there any difference in this for loop versus this for loop from the idea point of view? Do these two for loops look the same? They look the same, right? So if you go back a few minutes before in the class, when I was talking about why did we end up writing while loops, right? So we had sum equal to sum plus 1, sum equal to sum plus 2, sum equal to sum plus 3. When you had this, you wrote a while loop and said while number less than 100, sum equal to sum plus number, right? Because the structure of these commands looked like they were repetitive. Hence, we could actually just use a while loop to call this. So now using the same idea, in a function, if the structure of a function looks the same, you can actually call that function within the function. So now I can, instead of doing this whole thing, I can just call this. I'll append a pipe at the end or a slash at the end. So I can just call it this way. And this should return my total file size. So I should be able to add up this to this one. Does this make sense? So instead of writing a loop here, what is the problem with writing a for loop? There is nothing wrong, right? I got it. I got what I wanted. What's the problem? Why is this? Actually, before we do, I'll illustrate the problem also and then go back here. So does this work for you guys before we continue any further? Does this work for you guys? Is it giving you, oops, I made a mistake somewhere. Oh, okay. So we'll see if it looks like in one of my invalid start, but okay, file pointer to. Let's try this. If that doesn't work, I'll try something else. Okay, so some of these files are. Once I'll check if the file encoding is UTF-8. Python check, because I think actually I'll just explicitly ignore for now if file name not equal to, because I know what is causing the problem. I just don't want to worry about that for now. Okay, this should do it hopefully. Nope, still not working. Let me see what's going on. Okay, so it was able to print all this. So one of these files is a bad file. Interesting. Let me see what I should do. Can't decode invalid start byte. Somebody might have given a suggestion. Oh, RB. Okay, let's treat it as RB. Okay, so now it's returning me a slightly different size, which is what I was expecting. So probably I don't need this funky thing also now. Okay, so does this look correct? I mean, like I uploaded a few files. Now I'm adding up and I got the length of all the files within this sample data folder. Yeah, you try changing just this to RB, right? Instead of R, change the read mode to RB instead of R. When you're opening the file, put it as RB, because when you use R, it's trying to read the file as a specific. The files are small because they are all 18,000 bytes. So 18,000 bytes times 1, 2, 3, 4, 5, 6, 7, 8 is about 144,000 bytes. Hence, it increased here by 144,000 or something. I think maybe some of them are not even 18,000 bytes. Okay, so yeah, this looks about right because I added up manually and it looks fine. So does this idea look fine so far? Any questions on how we are proceeding? We are trying to check if it's a file, we are trying to find its length. If it's not a file, we are assuming that it's a folder, and then we are trying to check the length of the files within that folder. What's the problem with this style? What happens if I upload another folder within this? So I add one more folder, test folder 2, and add files into that folder. Perfect. You got the same size, maybe Vidyut, you probably didn't add files into that. So now I'm going to upload a few small files, but from where? Maybe this. Okay, I'm going to upload a few small files. I'll not worry about uploading any large files. So just 3 small files. So now what should I do? I think it will still give me the same answer. It still is giving me this 5799. It didn't account for 3 more files. What should I do now? What is the max file size to be read? I don't know. What is the max file size it can read? It can read any file size, I'm assuming. Whatever you can upload here, it will read it, I think. So now that we have a second folder within a folder, what should we do? We would have to make another case, right? So put another else here. Is that what you mean? And then do what? Then again repeat this for loop, right? Right? Is there any other option other than repeating the for loop one more time? Can we use a function for this loop alone? Yeah, you can use a function for this loop alone. So do you guys see this issue? So if you're, is this, at least hope you see some pattern here. Are you seeing that we are calling the same for loop again and again and again? Right. When we tried to do the same thing here with sum of numbers, what did we do? We ended up creating a loop, right? So similar to the same idea as with a loop, whenever you see that your function has, or your code has repeating, no, not a while loop, we'll use some idea similar to a while loop. When you see your code has some part of your code is getting repetitively called like this, then you can break that part of the code that is getting repetitively called and make a function out of it. So this part is getting called repetitively, so you can make a function out of it. And then whenever you're calling it, you just call that function one more time instead of repeating this. I leave this alone here, so for comparison purposes, I'll now call this folder size 2. And within this, instead of repeating these for loops, I'll just call it as folder size 2 of folder name plus file name plus slash, because I'm expecting a slash at the end. We'll see a way to avoid that, and I'll remove all this. So I'm claiming this thing will also give the same thing, because I'm replacing my for loop with this function call again, right? So whenever you see a part of your code within your function repeating, especially a loop repeating, if you are repeating a part of your code, you can put it in a loop. Whenever you see a loop inside your code repeating, that's an ideal candidate to make a function and then call that function within the actual function itself. So the function is calling itself, and I would just have to add up the size to this. Let's see if this works. So file folder size 2 of folder name is this thing. Actually, I forgot that I need a slash. So this is now accounting for even the tiny 3 files that I added, and it's giving me a slightly bigger number than the previous number, which even this one should give right now. So let's see if both of these give the same number. Oh, this is not giving me the same number. Must have, this is even giving me a small, oh, slightly bigger number. Let's see, where did we go wrong? 5695 8290. 6 is close to this. So let's see what file names it's traversing through, and then we'll, oh. So the previous function returned this. Oh, test folder 1 and this one, 56958290. Okay, so somewhere we missed something. Let me see. Oh, is the previous one calling one of them? No, exactly the same code. Let me see what's causing this discrepancy. Oh, I probably reused the file name wrong. Oh, I completely used the file name wrong. I didn't add up correctly here. So this was folder name plus file name. Yeah, this is wrong. I should have done it as folder name plus file name plus slash plus subfile name. So see, this becomes like a variable problem, subfile name 2, and then this should be here plus slash, and now hopefully these two, and I probably should call this file pointer 3 just to be clear. So now let's see what does this do. Oops, somewhere I made a mistake. Most probably. So here slash. Okay, so 56958290, and this is also giving me 56958290. Right, so both of these functions are giving me the same thing. As you can see, this second function looks so simple and straightforward. The first function is becoming like a big variable for loop tree, right? It's going deeper and deeper into for loops. Yeah, again, yeah, thank you. So this first function is becoming more and more harder to write and more harder to extend. And I don't know, right? How many times I should repeat the for loop within my for loop? I have no way. So these are the two guiding principles for when, and this way of calling function is called recursive function call, right? So you would make a recursive function when two conditions are satisfied. First one, when you don't know, when a loop within your code is repeating again and again and again, right? When a loop is repeating, especially in this kind of a tree kind of manner, if a loop is repeating in a tree kind of manner, because if it is not repeating in a tree kind of manner, then you can obviously use a for loop within a for loop. But here I can't use a for loop within a for loop because I don't know, there can be a folder within a folder within a folder within a folder. Hence, a for loop within a for loop only catches too deep, right? Yeah, so let me show this, right? So if I have a simple structure like this where there is a folder and a file, I can simply calculate the size with just this much. I can calculate the size of files, then I can calculate the size of files within that folder. But within my folder, if let's say I have again folders and files, then I need another for loop for each of these folders and another for loop for each for these files. And then within this folder, if I have again folders and files, I need a for loop for this and I need a for loop for the files, or summing up for the files. If this again has another file, so this has folders and files. This again has folders and files. This again has some folders and files. This is the last one. So as you can see, I started from here. This was the first layer at which I started. This is the second layer at which I went. Third layer, fourth layer, fifth layer, and sixth layer. So when there is, yeah, it's okay, Avnish, we can continue. You're very prompt at break. You can go to break. Whoever wants to go to break can go. Whoever wants to listen can stay. If you guys are that prompt about break until 11:05. Yeah, sure, you can go and use me. Yeah, so this is a 6-level deep folder path that I have. So if you have a problem where you don't know how many times your for loops have to continue, so then you don't know how many for loop within a for loop within a for loop you have to write. If you don't know that, and you have a loop that is already repeating, so if you don't know how many times your loop has to repeat, then you can call a recursive, then a recursive function call is a very good candidate in those situations. And the easiest way you can write a recursive function is first write out 1 or 2 rounds of this function, right? 1 or 2 rounds of your loop, and then notice the pattern, then replace the second one with your function call here. Replace this second one with simply the call to the function again. So we can take a break now up to 11:10, and then once we come back, we'll talk about one big problem with recursive function calls. You guys can take a break till 11:10. If anyone else has anyone has some questions, you can stay and ask. Otherwise, everyone can take a break. No, I'm not saying anything unless you guys want me. Oh, could you please explain the code for the recursive function? Sorry, I wasn't looking at the chat. Yeah, so Vijeta, if you let's just look at this one, right? So can you see my screen? Right. So I have a function, right? My goal right now in this class is to illustrate this one. So did you understand the first part where we calculated the size of the files within a folder? Did you understand that part? Okay, cool. Now, a folder can have folders or files, right? Is that clear? Right. Now, our function is calculating the size of the files within a folder. However, if our function encounters a folder, it's not doing anything, right? If it encounters a folder, it's just not doing anything. Does that make sense? Yes. Now, one way to make it do something is write a for loop. Every time it encounters a folder, write another for loop, and then calculate the length of all the files in that folder, right? That's one way to write it. That's what I was trying to do here, right? This piece was trying to say, hey, go through the folder. If you find a file, add the length of the file. If you find a folder, then again write another loop. Does this make sense? Okay. Now, unfortunately, what stops me from having a, like that would have worked for this kind of a folder, right? In this folder, there are no more folders again. All of these are files. These are either PDFs or this is some random file, right? So for this kind of a folder within a folder, that for loop would have worked. But if I go to a folder like this one, where I have again folders within a folder, now what should I do? Loop again, right? I should put a else and a loop again. So that one gave me this, right? So now I have three for loops. First for loop, this will find out at the topmost level. At the topmost level, if there are some files and folders. So actually, you can see from here maybe if I expand. So at the topmost level, if there are some files and folders, it will find the first layer's file size. This for loop is finding the size of the files at the first layer. This for loop is finding the size of the files in the second folder structure. Then I want to find out the files in the third folder structure. So this is the topmost. You can imagine this like a tree, right? This is at the topmost part of the tree. This is within the first branch. This is the branch of the branch. This is the branch of the branch of the branch, right? This is a branch from the branch again. You see the, do you see the analogy, or at least let's see, maybe I can draw in paint, right? It's almost like you have a tree at the top. You have a first branch and you have a second branch. Now this first branch branches into two branches. This branch branches into, let's say, 5 branches, right? This branch branches into 2 branches. For each branch, you need a for loop, right? That's what we have been writing. For each branch, we need a for loop. Each of those endpoints are folders, yes. Each of these circles that I'm drawing is a folder. I'm starting from here. Actually, I'll draw a better diagram, maybe in a linear fashion. So I'm starting from here. My folder at the top can branch into 2 separate folders. The middle ones are not folders. These are these you can think of as files. Each line you can think of as files. So this is a file, right? This is the list of all the files in that folder. Then this is these separate branches are the files within those folders. Oh, this is a folder. Yeah, each of these points. Oh, this one, no, this is just to show that. Okay, I'll draw a better way then. So this folder has 2 folders, right? And then each of these 2 folders, let's say, has 3 folders or any number of folders. If the number was fixed, then it would have been easy, right? This one has a separate folder, and let's say this one has 2 more folders. This one has 2 more folders, right? Now we need a for loop for each of these circles, right? So we need a for loop to calculate the size of the files in each of these circles. Very badly drawn circles, but you believe me that they're circles. Okay. So first for loop, second for loop. Maybe the second for loop would work for both of these. Then you need a third layer of for loop which will work for these. A fourth layer of for loop which will work for these. Does this make sense? So instead of writing like 4 layers of for loops and then not know, because what is stopping me from having another layer of branches? Nothing, right? I can create one more set of subfolders within this, right? Nothing is stopping me from doing this. So since I don't know what is the number of layers that I have to keep on going, it is impractical to write for loops like this. So this is first layer for loop. This is second layer for loop. This is third layer for loop. I need a fourth layer for loop. I need a fifth layer for loop, right? And it's messy. Does this make sense? Instead of this, what I'm doing is each time I detect a folder, anytime I detect a folder, I'm just calling this function back again. Or sorry, I'm calling this function, the main function, back again. So let's say in each of these instances, I have a function to call. So this is my function. Instead of writing my for loop, I'm just calling this function back again. That's a better idea, right? Instead of repeating the for loops, each time I get this, I would call this function again. Right? Does that make sense? And since I'm actually going through this structure within my first function, right? My first function actually looks at a folder, then looks at the subfolder within a folder, because this listed AR is already giving me that list. Hence, I don't have to write a separate function. I can simply call itself, right? I can simply call itself and say, okay, start again from this point. I'm just saying start again from this point. Instead of saying start call another function, I just say start again from this point, and that's this one. So start again from this folder. And this way of doing it is called recursive function calls. Okay, hope everybody is back from the break. So we use recursive function calls when there is two situations. This is the best candidate, right? If you are repeating the same kind of code, especially the same kind of loop, and you don't know how many times you have to repeat. If you know how many times you have to repeat, you can simply use a for loop within a for loop. So this total folder structure, yes, this is called the recursive call, Medha, because I'm calling my function within the same function. That's a recursive function call. Now you guys understand the zip bomb, right? Because in a zip file is like a compressed version of folders within it. A zip file can have a folder, a zip file can have a zip file, and then it can have a zip file within it, a zip file, and the zip file within a zip file. So this zip bomb, all it does is it simply tries to keep creating zip files within zip files within zip files. So that's the zip bomb, or this virus is a big problem with recursive calls. So how do you know when should you end this function, right? When should this calling the function within a function within a function within a function end? When should it end? For this particular problem, when should it end? It should end. Yeah, it should end when you are done with folders within a file, right? Luckily, in most of the operating systems, you cannot have infinite folder within a folder within a folder within a folder problem, right? You can't have infinite of them. But what if you had infinite folder within a folder within a folder structure? Then this loop will run forever, right? That's exactly what's happening in this zip bomb thing. That loop is running forever because it's trying to open a folder, and then there is a folder within that, and then there is a folder within that, and so on. So if you keep on having infinite ones, so that's the two problems associated with in recursive calls. You can have infinite recursion. This is commonly called stack overflow. Of course, not just in this context. Stack overflow can result because of infinite recursion, right? So if you keep on calling your function within a function. So say we create a zip bomb in Colab. No, actually, yeah, that's what I'm about to tell you. So how do you prevent this? Stack overflow just means that your code is running too many loops within the same loop, right? So it's running enough times that there is not enough space in your RAM to run it any further. Yeah, stackoverflow.com actually came up because of that, because usually when you get a stack overflow, that means you're getting an error, right? So stackoverflow.com was supposed to be the place where you would go to find an answer to your problems. Though it has evolved into a much larger purpose. Anyway, so one problem is infinite recursion. So how do you stop a zip bomb from making your computer crash? If you're writing a program to open the zip bomb, how do you safely stop it from crashing? Any thoughts? Timeout, yeah, very nice. Timeout is one method. Any other methods? So what do you see? This tree has levels, right? Yeah, kill the execution, but how and when? So this tree has first level, second level, third level. When I say third level, it means you have to go through, this is the first one, second one, and third one. So when you come here, you would have already gone through 2 folders to get to this folder. So that's third level. This is fourth level, and this is fifth level, right? So if I have infinite levels and I don't want my program to crash, maybe create a fail-safe code using try accept. Try accept doesn't create any fail-safeness in this particular instance, Nipun, because there is nothing wrong with that code, right? It's not failing. Your computer crashes because there is no more space in your computer to do all this. No, there is nothing programmatically wrong. Programmatically, it completely is fine. The problem is you'll run out of memory on your computer. So you can set a, so what is one way you can do? So this is level 1, level 2, level 3, level 4, and level 5. So one way that, as Aditya said, you can put a timeout. The other way you can prevent an infinite recursion is by trying something related to these numbers that I'm just showing. How could you try? Any thoughts? Okay. How many levels should I proceed before I say I'm done? If I have a tree within a tree, with a folder within a folder within a folder, how many levels is it safe to proceed and then stop? You can randomly set some threshold and say, okay, I'll only look at, okay, 5. You can even do 50, right? You can do like 50 levels. And once you have gone through 50 levels, you can say, okay, this is too deep and I will not keep going along this path anymore, right? So one way is timeout. You can say how long it is taking. You can stop your program if it takes more than, let's say, 5 minutes or 50 minutes, whatever your threshold is. You can set some threshold and say, okay, I'll stop at this. Or you can set some number and say, okay, I'll stop at this level. Both are exactly the same idea. One is time-based idea, other is level-based idea. That's the same idea. So that's one way to stop recursion. The second thing that you should always know in a recursive function call is that you should do the work at some point. Some recursive function calls forget that and they don't do the work. Like this is a poor recursive function call, right? So if I remove this part and then just put, let's say, total folder size equal to total folder size. Obviously, you'll never do this consciously, but if you write a very long recursive function call, it might end up being like this. So the best way that, at least in practice, that has helped me most is I almost always end up writing, unless it's a very simple thing, I write the first loop, then I write the second loop. Once I see the pattern, I then replace this second call with just the first call to the same function. That way I'm not making a mistake of not doing the work, because there are a lot of programming quizzes in which this is the problem. Like your recursive function call is actually not doing anything. It's a good recursive function call, but it doesn't do anything. So you should know your termination condition to stop your recursive call, and you should know some condition to make your program, make your function do some work. So in this example, what is the condition that I have to check before I go and check the size of a file? What is the condition that I have to check? What condition is there before my actual work statement? What is the if statement before this? Anybody? What is the if statement before this block of code that I have highlighted? Is file, right? So because I'm trying to find the length of the file, I'm checking to see if it is a file, then find the length of the file. If it is not a file, call my function back again, right? So like is numeric, exactly like is numeric. Yeah, it works a slightly different way, but same idea. Yeah. So this is my condition to make my function do some work, and within that block I have to do some work. And this is my condition to make my function call itself again. So there is a branching call or a recursive call condition, and a work condition. In this case, I don't have a termination condition because I know in Windows or in Colab, I know I can't have an infinite folder structure. So I don't have a termination condition. So you'll have three blocks at least. You'll have a condition to call your function back again, condition to perform some function, perform the work your function does, and termination condition. This is optional, but if you don't have, in some cases you might need this. So a recursive call has three pieces. This is first piece, this is the first piece, this is the second piece, and we don't have a third piece because in this program it doesn't make sense to have it will never have a problem with that. So this is about recursive calls. The most simplest example that people take when recursive calls are introduced, some of you might have already known, is calculate factorial, right? So define factorial of a number, right? So can you try to calculate factorial of a number using a recursive call? So this is an exercise for you guys. Try now in the next 8 minutes. Write a function that calculates factorial of a number using a recursive function call. And assume don't worry about input. Give a number greater than 1 as input, right? So you don't even have to worry about inputs. So how do you calculate factorial using a recursive function call? Okay, is it clear? Like, if you have questions about how to start or how to proceed, let me know. Otherwise, you can start. Oh, because I just need an input point, right? Like a starting point. This variable should hold some value. I'm just initializing it with 1. I didn't write any code here. Calculate factorial of number using recursive call. This is just a method stub. So for those of you who don't know how to start, let's say I have any advantage using a recursive call. Yes, there are some advantages. In the folder example that we saw, do you see the advantage of this code? Was this code good? No, not for this problem. I'm talking about in classes of problems. In a problem where you want if you are repeating loops, then this is definitely recursive call is much more advantageous. The second advantage has more to do about how memory is allocated, which we have never spoken, so I don't want to introduce that one right here. But there is an advantage to recursive function calls because in terms of memory allocation, they are actually slightly more efficient than loops. Because just to illustrate that point, right? When I write a for loop here, it's creating a list and doing some for loop for that. So it has to keep track of where it is within that for loop. When I write this for loop, it has to keep track of that. When I write this for loop, it has to keep track of another for loop within that. So when I'm linearly expanding like this, it's a little difficult for it to manage memory because it has to keep giving it more and more memory to do this. Whereas when I do this recursively, it can actually suspend processing of this for loop, the previous for loop, and allocate memory for the working of this second execution of that function. So there is a decent advantage. And the reason is because of this return statement, right? Because when I call a function, I know a function will have a finite return. So till it returns, I don't have to keep worrying about what happened in the previous for loop that led to this call. So I can throw the interpreter or the compiler can suspend the execution, or can suspend the execution of the previous function call. Okay, for anyone who has not been able to start it, let's try to do a simple one. What is 5 factorial for those who have not started or who are having difficulty starting? How do you calculate 5 factorial? Of course, yeah, 120, but how do you calculate? Yeah, it's 120. Okay, so you do 5 times, 4 times, 3 times, 2 times 1, right? So if you wanted to write a for loop, how would you do this? Okay, that's one way. That's a good way. So if you wanted to do a for loop, you could do it as for number in range 1 comma limit plus 1, right? Okay, good. And then you just multiply this, right? I think we did it already once in homework of some class. This is with a function, with a for loop, right? You're all familiar with this because I think we did it. I'm pretty confident we did. Yeah, okay, Avanish says we did it. Yeah, very nice. Sorry, not return, just print. Right, so this is going to give us 5 factorial, very easy stuff, nothing complicated. Right, so this is using a for loop. You can obviously also do it as opposite in the range. So you can do limit comma 0 comma minus 1, right? So you can go in the opposite direction and do the same thing, and it will give the same thing, right? Now, how do you calculate this recursively? So when I had 5, I'm multiplying with 5 minus 1, right? Then I'm taking 5 minus 1 and multiplying 5 minus 1 with minus 1 of that, right? Then I'm taking 5 minus 1 minus 1, and I'm taking a minus 1 of this, right? This is a recursive way of doing this. Absolutely no advantage doing it recursively. In fact, actually, in most practical cases, this is probably much more beneficial. So you can make the 5 minus 1 part of the function, right? So if I'm calling a function with factorial of number, then what do I do if I'm calling this function as factorial of number? So this is the first point, and then I can call the function again with the number minus 1, right? So I call it number times factorial of number minus 1. But can I do it infinitely? When should I not multiply? When should I stop calling this function? When it reaches 1. What reaches 1? When number minus 1 reaches 1, right? Or if number is greater than 1, I can keep calling this. Else what? So if number becomes 1, what should happen? What is 1 factorial? 1. So I just return 1, right? If number becomes 1, then just return 1. Right? Or I can say factorial computed is equal to 1. And then if this is the case, then I would just return factorial computed, right? So if number is greater than 1, I'll keep calling it, else I'll just return the factorial computed, which is just 1, right? So let me write this factorial of a number. So if number greater than 1, I'll write it here. If number greater than 1, factorial equal to factorial times, sorry, factorial equal to number times factorial of number minus 1, else return factorial. So that's it. So let's see if this function works. I hope it works. Factorial of a number 120. So we'll give 50 and check. So some big number. Make sense? So it looks like it's working, right? So this is a recursive way of doing this. In this example, there is not much of an advantage. In fact, this looks much more easier, right? So just because you know recursion doesn't mean you should use recursion for everything. You should see where it makes sense. In this example, you knew you will stop at 50 or 5 or whatever. Your loop runs 5 times or 50 times. There was no loop within a loop within a loop within a loop. So this is a poor scenario of using recursion. Absolutely nothing wrong with using recursion, but not the best use of recursion. Whereas if your function had a loop within a loop within a loop, then that would, and you don't know how many of these things you should have, then that's a good use case for using recursion. This is more about when to use it. But if you use recursion, wouldn't it change the factorial variable back to 1 again? Very good point. Actually, I was waiting to see if somebody. So let me show you what happens. I'll print factorial here. Print number comma factorial. That will show you what's happening. Okay, I'll just call it with 5 because I don't want to waste a long space. So see what happened. The first time it called with 2, right? So the number was, but the number was 5, right? Never, actually, let me even call it here. I'll say print number, comma factorial instead of here. So see, first it went to 5. So first it printed 5 because it started with 5 and now factorial was 1. Then it printed 4 because it was, so at the start, and then as we compute, right? So first at the start it was 5, right? So it was 5. It simply ended up calling this function. It didn't do any multiplication. It just called the function again. There is no multiplication here because if it was multiplying, then it should have printed this as we compute, right? So first it calls it with 5 times factorial of 4. So it went and said, okay, 4. Then it again says 4 times factorial of 3, again went back. 3 times factorial of 2, again went to the top. 2 times factorial of 1, now it returns. So because it returns the factorial of 1, now it comes back to this part of the code because this is where you had called previously, right? The last time you ended up calling factorial function was from here. So it takes this 2 and multiplies to the 1 it returned and makes it a 2. Then it goes back one step further higher, takes the 2 that was returned from the previous function call, multiplies it to the 3 and makes it 6. Then goes back one step higher and takes the 4 that was there and multiplies it to the 6 from the previous one, gives you for 24. Then goes back one step previous and then does it 5. So it's almost like this in this tree thing that we had. We started off with 5 here. We didn't multiply. We said 5 times whatever is the output of this thing. Then we said 4 times whatever is the output of this thing. Then we said 3 times whatever is the output of this. Then we said 2 times whatever is the output of this. And finally we had 1 times the 1. So we returned 1 as output. So this takes 1 and puts it here, makes it a 2 and gives a 2 back to this one. This calculates this, makes it a 6 and gives the 6 back here. This calculates it, makes it a 24 and gives the 24 back here. So as we are going, we are not calculating. We are only calculating as we are coming back up. Does that make sense? Why does it come back? Because you're calling a function, right? When it is returning, when this function returns here, when this is returning, it's returning to whatever is calling it, not to the main function. This is the first call. But when this returns, this call is returning to this part. Right? So it's returning back to whatever is calling it. What called it when this part of this input with the input 1, which function called it or which statement called it with input 1? This statement called it with input as 1. Our main statement called it with input as 5, but this statement called it with input as 1. When it returns, it has to go to this part, not here. Right? The same as when we did folders. We went to this folder, we found out all the sum of the files at that folder. Then we went to this folder and found out the sum, right? But we kept using the same variable called total file size, right? Total folder size, which was becoming 0 each time. Because as you went to each folder, the total folder size of that folder is 0. Only when you loop through it, you know. But since you're returning at each time, you're returning and adding it to the previous function call. So same idea, whether you're multiplying or finding the folder size. As you can see, there is a small advantage when done right. Recursion is taking a small piece of work and propagating it upwards. So your number that you are multiplying and calculating is increasing over time, not decreasing is increasing slowly compared to what it would increase if you are doing in the opposite direction. If you would have done 5 times 4, you already got to 20 times 360. So this is already a bigger number than when you went from bottom to up. And depending on what kind of work you are doing, it may make a big difference. Of course, in multiplication of numbers, it may not make any difference. It absolutely won't make any difference if you are doing it with small number multiplication. But so this is where we'll stop. And if you have any questions, you can stay back after 12 o'clock. We can talk about that. Now let's talk about a couple of project ideas that I had, and see if you guys want to pick one of those, or you can pick any others. So the first project idea that I had, because some of you guys joined late, the next class is on December 5th, and then on December 19th, we have the final exam for this session of the course. Either you guys can choose to do a project for the final exam instead of the final exam, or you can do a final exam. It's up to you guys, no force. And there is no difference, you'll get exactly the same points. Project is better, yeah, project is definitely better. I strongly recommend whoever feels comfortable doing the project, please do the project, strongly recommended. But if you don't like projects, it's up to you, individual preference. Yeah, that's what. I will give you guys a few options. Today I'm going to discuss a couple of options and then ask you guys to come up with any other ideas that you may have. But I would like to evaluate that idea first. I don't want you guys to pick a small project like calculate factorial of a number and say this is my project for this group. Yes, so a couple of directions. So you can use project instead of final exam. It's a choice. You don't have to do it. You can do it. It's up to you guys. You can do the project as project can be done as a group. You can work on the project as a group or individually. If you work on as a group, everybody in the group gets the same score. If your project gets like 100 out of 100, all of you get 100. There is no division of layer. We will not see who did the most amount of work and give one person the most work or anything. Everybody gets the same score if you do it in the group. All of your group gets the same score. Okay. So it's evaluated for 100 points. And I'll give out some criteria on how we'll evaluate. You might have to make a presentation of how your code is working. So you'll have to give out a presentation, and it has to pass some input. It has to pass some input, some testing. We'll call your function or your project and give you some inputs. What does that mean? Like if the project is, let's say, calculate the factorial of a number, we'll give you like a number and it should calculate, and we'll check if that is the correct answer. So it has to pass some testing, and you have to give some presentation about why you did, how you did, and so on. And your code structure. Yeah.
So what is the point of points?
Sorry, what is the point of what?
What is the point of points? Like, why do you need to get points in this?
Oh, because at the end of the course, we have to give out a scoring for everybody.
Like, what happens
because
if you get a bad score?
Nothing happens.
Okay.
Yeah, I mean, we'll give out 3 prizes basically at the end of the course for this session. Whoever we'll add up your homework scores, we'll add up your quiz scores, and we'll add up the project score or the final exam score, everything, and then we'll find out who has done the best in the class, and we'll give out 3 prizes. I think they're called star awards. That's the same idea we were doing in Agora Math, so we'll continue the same idea. So you'll get a prize if you do well. But if you haven't done well throughout the course, and if you do well in the project, maybe we'll give the project a higher weightage. Let's say like project counts more. Workday where you can like help us. Yeah, we can do it after next class basically. Yeah. So let's talk about the projects in the next 15 minutes. So in the next, yeah, I'll answer your question, Nitin. I'll actually copy paste here so that I'll answer it before we finish. Okay, so the first project idea that I had is something that I already introduced you guys to. It's called Wordscape Solver, right? I don't know if you have used, please don't copy code. You have to explain your method. Some of you might have played this game called Wordscapes, right? So if the input to your code will be some letters, right? Whatever number of letters, and a grid, right? A grid with the right answer choices. That will be actually not right answer choices. Your project should be take this as input and then give this out as output. Of course, you don't have to paint like this in nice colorful way. You can just print. To assist with you, I will give a function for this project. I'll give a function which tells you, if you give me a word as input to it, my function will tell you whether the word belongs to the grid. If it belongs to the grid, where is it in the grid? So, or you guys can write that also. You guys can write that. You can make up your own grid and write it as part of your testing. During my testing or during your final testing, I will probably use my function to check. So you would write a function, you pre-decide a grid. If you want, you can pre-decide something like this, right? The answer here is ice probably. So you fix up a grid and you take input some 6 letters or 7 letters, generate all meaningful words from it and try to fill up this grid. But you don't know what the grid is, obviously. The part of your code that's trying to generate words, check these parts, doesn't know what the answer is. And the part that knows the answer doesn't care how you get the words. So it's almost like, yeah.
I have 2 questions. One, can we use tkinter for this?
Can you use what? Sorry, I didn't get it.
Tkinter. It's like
if you want to do UI, absolutely fine. If you want to do use.
Okay. And also the other thing is, can we use the code that we did I think like 2 classes ago, like the Wordscape one?
Yeah. You can use that code. So you can use if you use some UI scaling thing. So if you want to build UI like this, it's absolutely fine. You can build UI like this, but it's definitely not necessary. You can simply print like this. This is also good enough. So if you want to just do something like this, where your code simply prints, what was the diagram here? Oops. If your code simply prints this, So dash dash E, and then 4 more dashes. So if you print a two-dimensional matrix, that's good enough. You don't have to actually paint it nicely like that. If you just print a two-dimensional matrix, that's more than sufficient. And you guys have all done something like this, right? Oops, I forgot to make it a string. Right, this is good enough as a solution, right? So you can simply print the grid. It doesn't matter how you display the answer or how. What matters is that you solve it, right? And your code should return something like a grid, really something like a grid, so that I can check, right? I will call it with an input, and I will call it. I will tell you as you are running it whether my expected output grid has it, and I'll see how your code is performing. Like, does it take like 2 seconds to run, or does it take 200 seconds to run, or does it not finish at all? Because if you write poorly, it might not finish at all. So is this, if you guys need some more clarity thinking about the project, I can describe this to you guys separately for those who choose to do this one. So this is one project that I thought. This involves everything that we have learned so far. This involves two-dimensional lists. This involves recursion that we just learned. This involves opening a file and using dictionaries. This involves all the things we have learned so far. So this is nothing that you haven't learned so far, except if you want to build a UI, like I don't remember who was saying, can we make power-ups, extra credit? What is power-ups? I don't know what is power-ups.
Like the one where they give you hints and then you get like free bonus questions.
Oh, okay.
It's on
Just, like,
that.
extra.
Yeah, if you do extra things, you'll get extra points. Okay, sure. Yeah. Yeah, if you feel like doing extra things, great. You can definitely do it. I don't have any preference on that. And you don't have to. You shouldn't assume you'll get certain number of cells, right? Your grid size should be flexible. It can be 7 by 7 or it can be 5 by 5. Your grid size should be flexible. Your input letter should be minimum of I think 4, right? I think these games start at 4 letters or maybe 5 letters. So a minimum input length, you should not assume you'll only get 6 letters or 7 letters. Now, when I say grid, I mean this is a grid, right? When what you see here on the screen is a grid. It's just displayed in a nice colorful way, but this is a grid, programmatically speaking. Or this is a two-dimensional list, right? Some way of your program should output or input, should accept grid size. It should work for various grid sizes, and it should work for various input lengths, and should return a grid, whether you paint it fancifully like this or not. Okay, so that's one project idea. The second project idea that I had, what's this at the bottom of the screen? Oh, I didn't notice. Oh, Black Friday deals, yeah. So the second project idea is this very interesting. I've read this one. Now I'm not finding that book. Hopefully I could give you guys the name of the book you guys can read. Is some basketball analysis. How many of you know what's a hot hand? Okay. Okay. Any other game that you play or watch? Has there been any time where you like are playing amazingly well compared to how you normally play? Like for 20 minutes or for 10 minutes, you play so incredibly well compared to what you normally play? Okay, perfect. Yeah, is it when they make shots? Yeah, exactly. Yeah. Right. So in basketball, hot hand is when a player gets like 3-4 baskets in a row, or maybe 5 or 6 baskets in a row. So I'll download data about some basketball from some basketball team's performance. I don't know, maybe I'll download Lakers because I've used Lakers data sets in the past. So I'll download some Lakers data set, and from there you should find out if hot hand occurs in the data at all. And if it does, is it significant? And I'll define what does it mean to be significant. There'll be like a definition. So this is actually an introduction to the next part of the course, basically, because we will try to learn what does significant mean and how to analyze data. This, whoever wants to do this are probably preparing a little bit for the next part of the class, where we are going to do some data analysis, or where we are going to do some artificial intelligence, machine learning stuff. So this is just analysis. This is not machine learning. No, not sure. Let's think about it. Hangman, not sure. Are you talking about the analysis where it says, yeah, hot hands doesn't actually exist and that it is only probability? Yeah, something like that. Yes, yeah, something like that. It's actually not that easy, Shreyan. You have to, the way I define significant will make it little difficult to actually detect, right? You will actually find that it is, it looks like it is there, but I'll see. Maybe I'll extend this problem a little bit to make it worthwhile, right? Maybe you'll have to find the players with the most hot hands, or the players with the most hot hands in the first quarter, but the worst players in the fourth quarter, and so on. Oh, you're Satvik and you have a plan. Very nice. Okay, so that's the second one that is useful. The third one is also something similar. So you can either do this. The third one is also similar to this. It's also about some statistics and some learning. It's called Bible codes. Have any one of you heard of it? Those who took the who attended the class last time, the session that I did last year, I think might have heard of this. It's called Bible Code. What this is there's this guy called Michael Drosnin. He publishes this book where he says Bible contains these amazing strings, right? Where it tells you the future. So like this guy, if you notice here, it's telling him the future: Twin Towers, airplane, terror, Shaheed, twofold strikes, will collapse, will burn. So he says Bible has predicted already that the 9/11 attack will happen using two flights. Two flights will strike Twin Towers and it will collapse and will burn and a lot of people will be martyred. So this guy claims that yes, it already had predicted all this, right? No, actually he has predicted a lot more things. Yeah, absolutely. For most people, it will sound crazy, but there is actually a very big following for this guy. His book is, I think, in 10th edition now, or 7th edition. So it's a New York Times bestseller. So you know what? The next edition that guy publishes, I'm sure he will say, you know what? This book had already predicted COVID, right? So this is a very challenging problem because it takes a lot of computational resources. And as you can see in this picture, right? As you saw in this picture, the way he predicts is very interesting. He jumps, right? He starts from one letter, jumps 30 letters, jumps 30 letters, jumps 30 letters. Starts from another letter, jumps 50 letters, jumps 50 letters, or something like this, right? And there is no fixed thing. It just keeps jumping. Does it make sense? It keeps jumping sequences. And he merges those jumped sequences to make sentences. 5 more minutes, Meghna. So this is the second one. Both of these are really talking about same kind of thing. So I will give you like a text version of Bible. And then you should make your code start with different points, start with different jumps, and find meaningful words, and then see if it forms meaningful phrases and see if you predict anything accurate. Of course, you have to do this in an optimal manner. Yeah, that seems complicated. That's why it's a project, right? Otherwise, it would be a homework. It's a complicated thing in terms of how you optimize it, right? You have to optimize it to abandon things ahead of time. Oh, I don't know if yeah, maybe he died. I don't know. then maybe he wouldn't have predicted COVID. Maybe some follower, maybe he has a follower. I never know. He might have passed on his follower thing to some follower. Yeah, he died in June. You're right. Yeah, so he died in June. So hopefully he's there. He doesn't predict anything else, but I don't know. Maybe his followers will predict that COVID was already known. Anyway, so this is another one. This is complicated, but it's something that is very useful for the second part of your course. So those of you who want to see about optimizing functions and working with larger data sets, maybe you guys can try this. Any other ideas that you guys have? So I'll just maybe the top 3 ideas. The first 3 ideas somebody presents, I'll see if we can consider those. So anyone, if you have any other ideas, these are the 3 ideas. These 2 ideas help for the second part of the course. The first idea helps you like get a understanding about the first part of the course. I haven't had too much time to think about other ideas, but hangman or ciphering a secret code. Ciphers only test one type of thing, right? Like any type of cipher really just tests one type of coding, right? In fact, actually most ciphers, when you implement, they are actually just 4 or 5 lines of code. Right? So cipher, algorithms, implementation. So unless you want to do a very hard or complex cipher, right? Any substitution ciphers are very trivial in terms of code, right? Or yeah, unless you want to implement a lot of ciphers, very different kinds of ciphers. Like you want to implement some block-based ciphers, some substitutional ciphers, some cryptography-based ciphers, then I'm okay with it. But you have to study a lot for that. Yeah, I know. Yeah, that's actually those are simple substitutional ciphers. The code for that is only a few lines. Enigma machine. If you want to implement Enigma machine, absolutely, yeah, you can definitely implement Enigma like thing. That's a very interesting project you can try. Because Enigma is a revolving cipher, right? So it's the cipher text is changing and it's a revolving cipher. It's difficult to implement. So if you want to do some complex ciphers, absolutely fine. Like any revolving cipher, any block-based ciphers, along with some simple ciphers, absolutely fine. Anything relating websites? Yeah, I was actually thinking this morning about some websites, but I don't know how many of you guys know how to do like some web crawler or like one thought I had was I can maybe even give you like some starting code. No, not building websites. Yeah, no, not building websites. One thought was like you could give a Wikipedia page, right? Like so display like a Wikipedia link and some summary of that Wikipedia link, maybe the first 100 characters in the Wikipedia link. Yeah, class is over. We are discussing. Yeah, class is over. We are just discussing project ideas. If somebody wants to leave, you can leave. But you guys have to choose within the next 3 or 4 days. So by next Saturday, you have to choose, or by next Friday evening, you have to choose whether you'll do a project or not. First of all, that's one thing. And if you're doing a project, which project will you do? So the 4 project ideas that are there so far, get HTML from websites, not really that, but you can get read Wikipedia, right? Read Wikipedia, get a page and the first 100 characters of it, and then if user likes it, then get the remaining page, else get another page. Right. This is not really that complex. I think it's relatively simple, but it's testing ideas that we haven't learned in this class. That's why I was not very comfortable giving it. But if somebody who knows how to do this kind of stuff, if you know how to get HTML from websites, if you know how to request something from a website, how to get data, you can absolutely do this. There is no problem with this. Similar websites based on keywords, actually that's not a mini AI thing. It's a very big, I think. Unless you want to build like a very, very basic thing, yeah, you can do that. So yeah, Nipun says he can try to find similar websites, but how do you find similar websites, right? You're going through some list of websites, right, to see similar websites. So that part I'm not sure if that's a mini project or a reasonable size project. I think what you're talking about is more like a search engine. A search engine takes some time to do if you are trying to do anything reasonable. Any other thoughts? Anyone who wants to pick up like some complex stuff or some easy stuff? Okay, just print HTML from website. Again, that's not something that really, like a Google search, it finds words in the query. So the way Nipun Google search works is because Google has a gigantic database of whatever it has crawled through all the websites. So without sorry, got a call. So not very keen. Anyways, you guys can choose. So dictionary which suggests words if you, that's actually a good one. Yeah, actually this is a good suggestion. So any sort of mistyped word correction, right? Like when Google corrects, or mistyped sentence correction even. So mistyped sentence correction. So this one you can do actually in a certain ways, like how you identify. So maybe for those of you who are not familiar, there are ways to do this. One is called Hamming distance. You can implement a Hamming distance. The other is called Levenshtein-Durbin distance. You can implement a Levenshtein-Durbin thing and see how to find out what's the distance between two strings, and anything that's close, you can suggest that. There are other, what are other distances? Hamming distance, Levenshtein, string distances, string metrics, and yeah, lot of distances. I think these two are the easiest ones to implement, Hamming and Levenshtein. And then there is just Levenshtein instead of Levenshtein-Durbin, I think. Yeah. So if you want, you can try this. So this is actually a reasonable, pretty cool project. You can try this one. This also involves loops. This also involves functions. This also involves looking up code. Turn simple pseudocode to that. Nipun, that could be a lot of work. Yeah, not something that we could do. Anyways, I think right now we have, I think 6 projects as I originally intended. So any other projects you guys can suggest, you can suggest. So the 6 projects that I think are, one is this wordscape solver, which is actually a very good project. If whoever wants to choose that, there is a lot of stuff to do. Make a calculator, unless it's really straightforward, right? What will you test within a calculator? You write a single function and you take few inputs and you're done, right? What will you test in a calculator? Yeah, if you choose to do a project, you don't have to do final exam. During the day of the final exam, we'll have a presentation. So instead of final exam, you'll have like a 15-minute presentation or a 10-minute presentation on your project. Okay, so we have 6 projects at this point. First project is wordscape solver. Second project is some basketball analytics. I'll see what kind of things we can analyze. I don't know. We'll give some data, and it will be simple analysis. It will not be complex analysis, but getting used to data analysis. Third project would be Bible codes, finding this some meaningful words by doing this trick that this guy has been doing, and then trying to form sentences out of those. Something interesting. I don't know. It's difficult because you have to optimize your code. Fourth one is ciphers. If you want to build any cipher other than very simple substitution ciphers. Ciphers, for those of you who don't know, are like taking a word like tank and converting it into HANTK, right? So that's not, of course, it's no longer easy to find out that it is tank, but by following a certain scheme, you can probably get to that one. So you can implement ciphers because that tests reasonably a lot of things we learned. Or for those of you who are interested, you can implement get a Wikipedia page, and if the user likes it, get another page. Or maybe you can implement search Wikipedia pages to get some word. User gives a word and you search through Wikipedia pages to get that. That's very complex, so I don't know if you want to go with that. Unless if you know what to do, then it's not that difficult. Then mistyped word correction. So if somebody types a word incorrectly, you have to suggest what are the best possible options. So these are the 6 projects. If you want to choose something else, you can choose, but you have to email your instructor on the chat window before next Friday, and we have to agree before next Friday. So before next Friday, you guys are supposed to email what is your group and what is your project, and we should have approved that project, right? There is no problem if all of you choose one project or more than one of you choose one project. That's absolutely fine. By next Friday, so 27th. Actually, you know what, this being Thanksgiving break, I know you guys will probably have plans. So you can choose by, let's say, no, you don't have to work in a group. You can do it can be an individual project or group project. You can do that. You can do one of these projects or suggest a new project. And if we accept that project, you can continue to do that project. No restrictions. I'm trying to be open-ended. Yeah, if you don't know someone, the best option is probably like trying to see if any one of you are trying to look to form a group, maybe you can message and we can connect you guys with groups. If anybody wants to do in a group and doesn't know doesn't know anyone to pick, you can message in the message center and we'll suggest like some partners you can work with. Okay, so if you guys have no other questions, thanks for staying a few minutes long. Hope you guys have a good Thanksgiving break.
Bye.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramastercode.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the